So in the last session, we were discussing about the thermometer. This is about expansion. We already discussed related to this. So if you want to measure a temperature, we are using a thermometer. And the features liquid in a glass thermometer. What are the features of liquid in a glass thermometer? The first one we discussed the sensitivity. Sensitivity means for a small change in temperature, there's a greater change in the level of the liquid. So the right hand side thermometer is more sensitive as compared to left hand side because it shows a greater expansion. The second we discussed the range. Range means the minimum and the maximum value which thermometer can record. So normally clinical thermometer have a small range as compared to laboratory thermometer. Responsiveness or quick acting. What is the meaning of responsiveness or quick acting? It refers to a time taken by thermometer to show a change in temperature. So the time taken by thermometer to show change in the temperature refers to responsiveness or quick acting. We use the term responsiveness, or we can also say quick acting. So how we can make a thermometer responsive or quick acting, or what is the meaning? Like example, you're inside the room and you have two thermometers A and B with you. You move outside the room where the temperature is 40 degrees. So inside the room the temperature is 30, but outside the room the temperature is 40. The thermometer A took 4 seconds to show the temperature changes to 40, whereas thermometer B took only 2 seconds to show that the outside temperature is changed from 30 to 40, or temperature changes from 30 to 40. Which thermometer is responsive or quick acting? Which thermometer is responding quickly, or which thermometer is quick acting? A or B? The thermometer which take a short time to show a change in temperature. So in that case, B is responsive because B is showing in a 2 seconds it shows temperature changes from 30 to 40. But A is taking time to show a change in temperature. So the thermometer which take a short time, to show a change in temperature, we call that thermometer to be more responsive. And how we can make a thermometer more responsive? So what we can use? If we use a thinner glass bulb, the liquid is there inside the bulb. So we can use thick walls for the bulb of a thermometer, and there is a capillary, or we can use thin walls for the bulb of a thermometer. So which one you think will be more responsive? Which one will react or to the heat of the surrounding? Is it A or B? And both are filled with the same amount and same type of liquid. The liquid is there inside the bulb. Here also liquid is there inside the bulb. So which thermometer can absorb heat quickly from the surrounding? The thermometer with the thin walls. Because thin walls are there, heat can easily transfer, but this one is having a thick walls. So heat it will absorb, but it will take time to absorb the heat energy. So the correct answer is, because the thermometer bulb is made up of glass, and glass is not a very good conductor of heat. So when it is a thin glass bulb, it will be more responsive. That heat can easily transfer to the liquid. If it's a thick glass bulb, the heat cannot transfer easily to the liquid, so it will take time to absorb the heat energy. So in this example, B is more responsive compared to A. So whenever we want to make a thermometer more responsive, what we should do? We should use a thin glass bulb. And there's also another thing what we can do. We can blacken the bulb of a thermometer, because black surfaces are good absorber of heat energy, so it can absorb the heat quickly. So second thing what we can do, we can blacken the thermometer. So if we blacken the thermometer bulb, like if you have two thermometers, one is having a light color bulb, another one is having a dark color bulb, both are same size. So which one will be more responsive, which one will react to the surrounding quickly? The one which is having a dark color, because dull and dark surfaces are good absorbers, so black color will absorb more energy, and it is absorbing energy much quicker as compared to a light color. And that is the same reason in summer we prefer to wear the light color clothes, but in winter we prefer to wear dark colors, because they can absorb greater amount of heat energy. Is it clear, the concept of responsiveness? Any doubt till this point? The responsiveness of a thermometer? Then the last one is known as a linearity or a linear scale. What is the difference between linearity, or what is the meaning of linearity or a linear scale? The linearity or a linear scale means that if you have equal spacing between the marking of the thermometer, we call that as a linear scale. Example, you have two thermometers, and the marking or the number, it's written 10 here, 11, 12, 13, 14. And here it's written 10, 11, 12, 13. So what is the meaning of linear scale? Linear scale means when a thermometer is having an equal spacing or equal distance between the marking, we call that as a linear scale. So A is a linear scale, where B is a non-linear scale. And the scale of the thermometer, linearity or linear scale of a thermometer, does not depend on the features of the thermometer. It depends on the type of the liquid which we use. Because some of the liquid, they expand linearly, like they have equal change in the volume, but some of the liquid does not expand linearly. So example, if we have a thermometer which is filled with alcohol, another thermometer filled with mercury, and there's another thermometer which is filled with water. The bulb of a thermometer is filled with water. So when we observe the change for alcohol, the numbers, like example, if it is 11 or 10 is there, then 11, 12, 13. In case of mercury, it example minus 10, 0, 10, 20, 30, 40, 50, till 90. And when we use water, for example, it is 0, 10 is there, 20 is there, and 30. So this was alcohol, mercury, and water. So when we check the scale, what about the scale of the alcohol thermometer? Is it linear or non-linear? Scale of the alcohol thermometer, is it linear or non-linear? So because it's a equal spacing, so that is a linear scale. What about mercury? Is it linear or non-linear? That also linear because equal spacing. But when we check water, that is a non-linear scale. It does not have equal spacing. So that is the main reason why we don't use water in the bulb of a thermometer, because when water expands, it does not expand linearly, and the spacing of the between the marking of the thermometer will not be uniform. So that is the reason why the water is not used in the bulb of a thermometer. Now, when I compare alcohol and mercury, which thermometer is more sensitive? I'm just talking about two of them. I have an alcohol thermometer and mercury thermometer. Which one is more sensitive? Sensitivity refers to the spacing between the marking. If there's a greater spacing between the 1 degree mark, it means that is more sensitive. So which is more sensitive? That's good. It is alcohol. Which is having a greater range? Mercury. And if I say alcohol thermometer take 30 seconds to show a change in temperature 1 degree, and mercury thermometer only take 10 seconds. So which is responsive? Which is a responsive thermometer? Only comparison is there between alcohol and mercury. You don't have to because water is not used in a thermometer. Alcohol thermometer take 30 seconds to respond. Mercury thermometer take 10 seconds to respond. So which is? So in that case, yes, that's right. Mercury is more responsive as compared to that of alcohol thermometer. So for every thermometer, how to check the thermometers? So for every thermometer, we call two things. We call lower fixed point, that is the temperature of 0 degree centigrade. And which substance is having a 0 degree centigrade? How we can check the 0 degree centigrade? That is the temperature of pure melting ice. So 0 degree mark on the thermometer is refers to lower fixed point. And what is upper fixed point? Upper fixed point, the 100 degree mark is refers to upper fixed point and that is the temperature of pure boiling water. So these are refers to the two fixed point of a thermometer. One is called upper fixed point, another one is known as the lower fixed point. So whenever they ask and give you or show you the thermometer, so what are the two fixed point of a thermometer? One is known as the lower fixed point, which is 0 degrees centigrade, and that is the temperature of a pure melting ice. And another one is upper fixed point, which is 100 degrees centigrade, that is refers to the temperature of a pure boiling water. So for thermometers, the things which you have to learn: number one, what is sensitivity? You should understand the fact what is sensitivity and how it can be changed. What is the range and how it can be changed. Responsiveness or quick acting. And the last one is linearity. So how we can use an unmarked thermometer? To find the temperature. So if there's a thermometer, it does not have any marking. How you can use it to mark or find the temperature? Say this is the bulb of a thermometer and this is a capillary. And this thermometer is not having any marking. There is no number written on this thermometer. And I want to find the temperature of this object. So we want to find the temperature of the object, but there is no number written on this thermometer. If no number is written on the thermometer, how this thermometer can be used to find the temperature? So first what we do, first we will place the thermometer into pure melting ice to mark 0 degrees centigrade. So first what we did, we placed this thermometer in a pure melting ice to mark 0. So example, when we place this thermometer in a pure melting ice, the level of the liquid rises to this point. This is a position where the level of the liquid rises. So if level of the liquid rises to this point, a pure melting ice means ice is melting, that's called a pure melting ice. Why I am using a term pure? Because the pure melting ice will have 0 degrees centigrade. So we place the thermometer in a pure melting ice because we know the temperature of a pure melting ice is 0. So when we work out if the liquid level rises to this point, so this is 0 degree. Is it clear, the first part? Because we want to find the temperature of an object for unmarked thermometer. Unmarked thermometer, a thermometer which does not have any marking. So we place the thermometer in a pure melting ice and we mark 0. Then what we do? We will place the thermometer into pure boiling water to mark 100 degrees centigrade. So when we place in a pure boiling water, the level of the liquid, it will expand more, and to one point, the last point where it stop expanding, it means that point is 100 degree centigrade. So this is 100 degree centigrade. So now we have 0, we have the marking on 0, and we have 100. Then what we do, we'll measure the distance between 0 and 100. So we will measure the distance between 0 degrees and 100 degrees. For example, if I say that distance is equals to 20 centimeter. So the distance between 0 degree and 100 degrees is equals to 20 centimeter. So now we have the scale. For example, we know 100 degrees is equals to 20 centimeter. Then the last point, what we do, we will place the object and record its length or the temperature. So example, we place the object and the level of the liquid when we place the object, because the object should be in contact. So when we place this object, the level of the liquid rises to this level, to new position. So this is when the object is placed. So what we do, we will measure the distance from 0 degree to the object, the position where the level rises when the object is placed. Example, this was 4 centimeter. So how we can work out the temperature? For 100 degree, it was 20 centimeter. And for 4 centimeter, what should be the temperature? X. Now cross multiply, 4 will be multiplied by 100 and 20 will be multiplied by x. So it will be 20x is equals to 400, or x is equals to 400 divided by 20. So x is equals to 20 degree centigrade. So this object temperature is 20 degree centigrade. Is it clear how we use an unmarked thermometer to measure the temperature of an object? So in the beginning, the thermometer was not having any marking. So first we place in a pure melting ice, then we place in a pure boiling water. So we have the scale number, like we know that if it is 100 degree, the temperature, 100 degree change of temperature equal to 20 centimeter change in length. And then we place the object, and remember one thing, whenever we measure the distance of the temperature for object, we always measure from 0, don't measure from the bulb. It is not measured from the bulb, all the distances are measured from 0. So I'll give another example. Say this is a thermometer, and here's a capillary. So when placed in the pure boiling, pure melting ice, the level rise by 2 centimeter. So first, when we place this in a pure melting ice, the level rise by 2 centimeter. The increase in the level of the liquid is 2 centimeters. So it means this is 0 degree and the level changes by 2 centimeter. When placed in the pure boiling water, the level rise by 22 centimeter from the bulb. So when we place in a pure boiling water, the level rises to 22 centimeter from the bulb. So this is a bulb. So the level rises from the bulb 22 centimeter. So this is 22 centimeter. And here is 100 degrees. So what is the difference between 0 and 100 degrees for this thermometer? What is the difference between 0 and 100 degree? That is 20. That's right. So it means that 100 degrees is equal to 20 centimeter. Now the question is, find the temperature of object when the level rise to 6 centimeter or 8 centimeter from the bulb. So we have to find the temperature of an object when the level rises to 8 centimeter or the level changes to 8 centimeter from the bulb. So when we place the object the level changes to 8 centimeter from the bulb. So this is 8 centimeter. We want to find the temperature of object. So how to find the temperature of this object? As we know, 100 degrees centigrade is 20 centimeter. But what about this length? I told whenever we take a length or whenever we find the length, we always take the length from 0. Like how much it rises from 0. So how much it rises from 0, that length we take when we are determining the object. So from 0, if total length from the bulb is 8 centimeter and the length of the 0 is 2 centimeters, so this length rise is 6 centimeter. So it will be 6 centimeter, that will be x and cross multiply. So 6 multiplied by 100, 600, and that is 20x. So 600 divided by 20 is equals to x, or x is equals to 30 degree centigrade. So the temperature of the object is actually 30 degree centigrade. Is it clear, this concept? That how we can use a liquid in a glass thermometer to find the temperature of an unknown object. Another example, because you will find these questions in MCQs, so it's better you understand the concept. This one I want everyone to solve, and state the answer in a chat. Say this was 0, this is 100, 4 centimeter, this is 14 centimeter, and when the object is placed, it rises to 8 centimeter or 10 centimeter. The question is, what is the temperature of object? Yeah, what is the temperature of object? When we place in the pure melting ice, it was 4 centimeter. When we place in a boiling water, it is 14 centimeter. And we place it in, the object is placed, it is now 10 centimeter. What is the temperature of the object? Yeah, that's right. So when it is at 0 mark, it was 4 centimeter. When it is 100 mark, it is 14 centimeter. So the difference from 0 to 100, that is 10 centimeter. So basically, the 10 centimeter, the 10 centimeter difference, this 10 centimeter means 100 degree centigrade. So if 10 centimeter is 100 degree centigrade, and now the object, because it rises to 10 centimeter from the bulb, so this length is 6 centimeter. So 6 centimeter will be equal to x. You cross multiply. When you solve 600 divided by 10, that's equal to 60 degree centigrade. So if the level of the object level is above the 0, it means it will be more than 0. And if it is below the 0, it will be less than 0. Is it clear, this concept of liquid in a glass thermometer? So today we discuss the consequences of thermal expansion, as well as the types of thermometer and the definitions which are related to the thermometers. Next session we'll do thermocouples. That will be the last topic of 2.2, and 2.3 is about methods of heat transfer.